performance questions. Why and when should one tune? One of the biggest responsibility of a DBA is to ensure that the Oracle database is tuned properly. The Oracle RDBM is highly tunable and allows the database to be monitored and adjusted to increase its performance. One should do performance tuning for the following reasons. The speed of computing might be wasting valuable human time. Enable your system to keep up with the speed business is conducted and optimize hardware usage to save money. Although this site is not overly concerned with hardware issues, one needs to remember that you cannot tune a Buick into Ferrari. Where should the tuning efforts be directed? Consider the following areas for tuning. The order in which steps are listed needs to be maintained to prevent tuning side effects. For example, it is no good increasing the buffer cache if you can reduce I/O by rewriting a SQL statement. Database design. Poor system performance usually results from poor database design. One should generally normalize to third normal form. Selective normalization can provide valuable performance improvement. When designing, always keep the data access path in mind. Also look at proper data partitioning, data replication, aggregation tables for decision support systems. Application tuning. Experience shows that approximately 80% of all Oracle system performance problems are resolved by coding optimal SQL. Also consider proper scheduling of batch tasks after peak working hours. Memory tuning. Properly size your database buffer, share full buffer cache, log buffer, etc. by looking at your wait events, buffer hit ratios, system swapping and paging, etc. You may also want to pin large objects into memory to prevent frequent reloads. Database I/O tuning. Database files need to be properly sized and placed to provide maximum disk subsystem throughput. Also look for frequent disk sorts, full table scan, missing indexes, row chaining, data fragmentation, etc. Eliminate database contention, study database logs, latches and wait events carefully and eliminate where possible. Tune the operating system if possible. Monitor and tune operating system, CPU, I/O and memory utilization. For more information, read the related Oracle FAQ dealing with your specific operating system. What tools and utilities does Oracle provide to assist with performance tuning? Oracle provides the following tools and utilities to assist with performance tuning. ADDM, Automatic Database Diagnostic Monitoring. When is cost-based optimization triggered? It is important to have statistics in all tables for the CBO to work correctly. If one table involved in a statement does not have statistics, the optimized dynamic sampling isn't performed. Oracle has to revert to rule-based optimization for that statement. So you really want for all tables to have statistics right away. It won't help much to have the larger tables and like generally the CBO can change the execution when you have appropriate statistics. Change statistics of objects by doing analyze. Change some initialization parameter, for example, hash, join, enable, source, sort area size, DB file, multi-block read count. How can one optimize XYZ queries? It is possible to improve XYZ queries by forcing the optimizer to scan all the entries from the index instead of the table. This can be done by specifying hints. If the index is physically smaller than the table, it will take less time to scan the entire index than to scan the entire table. Where can one find I/O statistics per table? The stats pack and utility stat report shows I/O per table space. However, they do not show which tables in the table space has the most I/O operations. The Oracle Home RDBMS cat.io.sql script creates a sample I/O procedure and table to gather the required information. After executing the procedure, one can do a simple select star from I/O per object to extract the required information. My query was fine last week and now it is slow. Why? The likely cause of this is because the execution plan has changed. Generate a current explain plan of the offending query and compare it to a previous one that was taken when the query was performing well. Usually the previous plan is not available. Some factors that can cause plan to change are the statistics have changed, there is some kind of change to the code, or the volume of the data has increased. Which tables are currently analyzed, were they previously analyzed? Has the optimizer been changed in the init.ra? Have the degree of parallelism been defined, changed on any table? Have the tables been reanalyzed? Were the tables analyzed using estimate or compute? If estimate, what percentage was used? Have the statistics changed? Has any init.ra parameter, DB file, multi-block read count been changed? Have the init or sort area size being changed, have any other parameters being changed. Those were some of the reasons why the execution plan would change. What do you think the plan should be? Run the query with hints to see if it produces required performance. It can also happen because of a very high watermark. Typically, when a table was big but now only contains a couple of records, still Oracle thinks needs to scan through all the blocks to see if they contain data. Does Oracle use MyIndex or not? One can use the index monitoring feature to check if indexes are used by an application or not. When the monitoring usage property is set for index, one can query the v.object underscore usage to see if the index is being used or not. From this view should be consulted as the owner of the object by interest. Okay. Why is Oracle not using a DAM index? This problem only arises when the query is being generated by the cost-based optimizer. The usual cause is because the CPU calculator executing a full table scan is much faster than accessing the table via the index. Fundamental things that can be checked are user tab columns, num distinct, num rows, and clustering factor. If the clustering factor approaches the number of blocks, the rows are ordered. If it approaches the number of rows, the rows are randomly ordered. In such a case, it is unlikely that index entries in the same leaf block will point to the row in the same data block. And decrease the DB file multi-block read count. Higher value will make the cost of full table scan cheaper. Remember that you must apply the leading column of the index for the index to be used. There are many other factors that affect the cost, but sometimes the above can help to show why an index is not being used by the CPU. If from checking the above, you still feel that the query should be using an index, try specifying an index hint. Obtain an explained plan of the query either using tkprof with time statistics so that one can see CPU utilization or with order trace to see the statistics. When should one rebuild an index? You can run the analyze index validate structure command on the affected indexes. Each invocation of this command creates a single row in the index tags view. This row is overwritten by the next analyze command. So copy the contents of the view into local table. Okay, for example, you may decide that the index should be rebuilt if more than 20% of its rows are deleted. How does one tune Oracle wait event? Here are some of the wait events from v.session, v.system event. DB file sequential read tunes equal to less IO. Make sure all objects are analyzed. Redistribute IO across disks. Right. Buffer with events. Increase the DB cache size. Analyze contention. Right. Log buffer space. Increase log buffer parameter or move log files to faster disk. Log file sync. If this event is in the top file, you are committing too often. Log file par write deals with flushing out the D2 log buffer to disk. Your disk may be too slow or you may have an IO bottleneck. The two useful section Oracle Database Performance Tuning Guide. Right. What is the difference between DB file sequential and scatter read? Both DB file sequential and scatter read signify time needed for IO read request to complete. Time is reported in hundreds of seconds for Oracle 8 release and below, and thousands of seconds for Oracle 9 and above. Most people confuse these events with each other as they think of how data is read from disk. Instead, they should think of how data is read into the SGA buffer cache. A sequential read operation reads data into contiguous memory. Single block IOs are usually the result of using indexes. This event is also used for rebuilding control file and reading data file headers. In general, this event is indicative of disk contention on index read. DB file scatter read. Similar to DB file sequential read, access the session is reading multiple data blocks and scatters them into different discontinuous buffers in the SGA. This statistic is normally indicating disk contention on full table scan. Rarely data from full table scan could be fitted into contiguous buffer area. These wait events show up for the session as sequential read instead of scatter read. The size of how does one tune the read log buffer? The size of read log buffer is determined by the log buffer parameter in SP file init.ra. The default setting is normally 512 KB or whichever is greater. This is a static parameter and size cannot be modified after the instance startup. When a transaction is committed, info in the read log buffer is written to the read log file. In addition to this, the following condition will trigger log writer to write the contents of log writer disk. Whenever the log buffer is minimum or 1/3 full, every 3 seconds, when DB writer process writes modified buffers to disk. Larger log buffer value reduce log file IO but may increase the time OLTP users have to wait for right operation to complete. In general, values between default and 1 to 3 MB are optimal. However, you may want to make it bigger to accommodate bulk data loading or to accommodate a system with fast CPUs or slow disk. Nevertheless, if you set this parameter to a value beyond 10, you should think twice about what you are doing. Statistics redo buffer allocation entries shows the number of times the user process waited for a space in the read log buffer. This value is cumulative, so monitor it over a period of time while your application is running. If this value is continuously increasing, consider increasing your log buffer. Relog space for wait time shows cumulative time waited by all processes waiting for space in the log buffer. If this value is low, your log buffer is most likely adequately set. Those were some of the points. Thank you for listening.